Hi, and welcome back to our beginner series. Today we're going to be doing an intro into forensics with Justin, but just for a moment, I have another announcement. I just want to remind everyone that on October 15th, junior exec applications are due. We had a meeting on September 29th for all you needed to know if you wanted to apply to be a junior exec. If you weren't able to make that, if you're just joining us and this maybe piques your interest, or you just haven't applied yet, please come talk to us. There's no experience required. You don't need to know anything about information security yet. We're looking for junior execs to just learn how to be an executive over the next year. You'll learn tons about information security. You'll have to do some work, but it will be great on your resume. And you'll just learn a lot and meet a lot of people. So I really recommend you apply. If you missed that meeting, I really recommend you DM me, Alexi, I go by Alex in our Discord, or Josh, Racina, just to ask about anything that you would need to know about being a junior exec. And you can send your applications to infosec.ucalgary@gmail.com. So I just wanted to remind everyone that that's coming up as a due date. And if you're interested, to please apply. So now I'm going to bring on Justin.
All right. Hi, everybody. Thanks, Alex, for the intro. So as you mentioned, I'll be hosting the Beginner Forensics Workshop. So let me go ahead and share my screen here. All right. So the tools you'll need for this workshop are StegHide and Binwalk, which you can run with the following commands up on the screen there. And as well, please don't forget to sign our attendance form by taking a picture of the QR code or visiting the bit.ly link in the chat. So yeah, I guess I'll just give you guys 30 seconds to do that. Yeah, the attendance form is just to let the club know that you attended the workshop, and it'll also assist in allowing you to vote to the AGM at the end of the year if you've attended half of the workshops. All right, so I think we're going to get started here. So thanks everybody for coming. This is very exciting. This is my first workshop. Wow. Okay. So I'll be talking about forensics in this workshop. So let's see what's in store for this workshop. So some topics we will be discussing: image steganography. So steganography refers to sort of hiding info or messages within pictures or audio files, file signatures, and Binwalk. So Binwalk is a forensics tool or pen testing tool that allows you to find embedded files for code and binary images. We'll be talking about audio file spectrograms, which I think is probably the coolest part of this workshop. Spectrograms are basically visual or electronic representations of an audio file. So you've probably seen one before. We'll be talking about some other basic forensics tools, as well as mounting and unmounting file systems. So that'll involve an image file or a .iso file that you'll have to mount and look for flags inside. So let's talk about what exactly is forensics. So you're probably familiar with the term forensics within the sort of criminology realm, which is like analyzing fingerprints or analyzing footprints. Although that is very cool, that's not what we're going to be doing in this workshop, unfortunately, but we're going to be doing something equally as fun. So forensics is basically dealing with static files or downloadable files within the cybersecurity definition. And it's sometimes seen as a catch-all category in terms of CTFs. So perhaps if there's a challenge that doesn't fit into binary exploitation or web exploitation, you'll probably end up in forensics. So it's almost like a miscellaneous category, if you will. And the thing about forensics is you need to be very clever about extracting the flag or extracting specific data from the file, because it could be practically anywhere within your static file. And you're going to use some analysis tools. Some of them will show you how to use within this workshop to extract the flag. All right. So we'll start with part 1, image steganography. So what is image steganography? Steganography refers to concealing one piece of data in another piece of data. So you can think about maybe having an image, like a .jpeg file, and hiding text or hiding some sort of message within that file. Or also, like another example is having an audio file and hiding text or hiding an image within that audio file. So the important point about image steganography is the resulting piece of data will look or sound the exact same as the original piece of data. So when we alter it to encode some sort of message or secret data, the resulting image or resulting audio file will look exactly the same as the original one. So let's talk about how we exactly do that. How can we add text or messages to a file without actually changing it? And someone is asking when the advanced workshop is scheduled for. It's happening right now. So we have a beginner workshop, which is on YouTube and Twitch, and the advanced workshop, disks, files, systems, and shares, is over on our Discord. So if you'd like to visit the advanced workshop, which Braden is holding, go over onto the Discord and you'll find it. Anyways, so here's a little, diagram of image steganography. So we have our original Mona Lisa picture on the left here, and we want to add a super secret file.txt into it. So we're going to embed it or encode it somehow into the image, and the resulting image is practically identical to the original. For all intents and purposes, you can't really see a difference between the two images. And one way we can do that is with a method called LSB Steganography. So if you're in your first year of computer science, or if you've passed your first year of computer science, you're probably familiar with the term LSB, which stands for least significant bit. This is the least weighted bit or the rightmost bit on a byte. And so what LSB steganography is, if we look at this diagram here, imagine this part on the left here is our an image file, and each of these rows represent 1 byte within the image file. And so if you remember, 1 byte is 8 bits. That's 1, 2, 3, 4, 5, 6, 7, 8. Yes. So with this image file, we want to encode a secret message. So this is our secret message in red. It's 1 byte in this example. It's 10110011. And what we're going to do is sort of encode each bit from the secret message onto the least significant bit of the original data file. So we take the first bit from our message, put it onto the LSB of the first byte, take the second bit, put it onto the LSB of the second byte, and so on and so forth until our entire message has been secretly encoded into the data file. So remember, the important part about steganography is that it doesn't alter the image. Like in this Mona Lisa example, the image is not changed, or it's not changed to the naked eye. So the way LSB steganography works basically is, because we're changing the least significant bit or the least weighted bit, if we think of this as like 1 pixel in an image, or 1 byte representing the color of 1 pixel in an image, if we change the LSB to a 1 or a 0, this is a very marginal change. So at most, it might change the shade of the color by 1 value. But overall, the naked eye will not be able to detect this change. So that's how this works. And here's a funny meme courtesy of Josh. We love a good car salesman meme. This bad boy can slap 1011 on your LSBs. So this example shows that this is our little secret message, and we put the bits onto the end of each of the bytes in the original data. So yeah, do you guys have any questions about this or anything specific that you might be a little bit confused about? If you do, just send it into the chat and I'll hopefully be able to see your message. But we're going to move on for now and talk about StegHide. So one way that we can do this encoding or embedding is with StegHide. And StegHide will allow us to do the embedding and also the extraction of hidden data. Another thing is StegHide sometimes will ask you for a password. If you don't think there's a password, just press enter. That is a hint for our upcoming challenge. And this is the command that we're going to be using. It's steghide extract -sf and then the name of our file. And it can be any file. So maybe we can demonstrate this. So if I type man steghide, this is the manual for StegHide. It'll show up all the information if you're interested in learning more about it. Also, just let me know if my text is not big enough. If you can't read, I can zoom in for you. But that's that. And if we want to use StegHide, you can write steghide extract -sf. I believe that was the command. And then the name of the file, for example, birds.jpg. That's where it is. Okay, so we can't open this specific file, but that was basically just to show you how the command works. All right, so another thing to point out is you should try StegHide first and then try StegoSuite. So what StegoSuite is it's the GUI version of StegHide. They are the same tool, but sometimes data can only be extracted with one or the other. So if you get stuck, try using StegHide and StegoSuite. That's I guess just a little tip there. But this brings us to our first challenge. I guess I should mention, for the challenge, StegHide should work. You probably won't need StegoSuite, but you can try it anyway if you're curious. This is our challenge here. So visit the link to download an image file, birds.jpg, and there will be 2 hidden flags within here. So see if you can find them. I'm just going to paste the link into the chat right now. And there's some useful information down here. There's the steghide command we use and some other tools that we could use. grep strings, which you may be familiar with from our first workshop. So I'll give you guys 25 minutes to try out this one. And of course, if you have any questions or if you're sort of stuck, not sure where to go, ask around, ask the chat. Maybe you can visit the Discord and see other people that are working on it. Good luck with this one.
Just jumping in to remind everyone, we love to see your progress, and it helps us space out how the workshop's going and how much time you guys need. So totally tell us if you get the flag, how many flags you have, if you need more time, etc. It just helps us out a lot.
Someone is asking, is there something I need to download to execute steghide? For some reason, it looks like this command is not recognized. Yes, make sure steghide is downloaded or installed on your system. Execute these commands, and it should install steghide for you. Someone is asking, what is the prefix for the keys? I'm not sure what you're asking. Oh, yes, you're referring to the format of the flags. It should be UC and then a curly bracket. So, and then within that, in the curly brackets will be the actual flag. No problem. someone asked, is the LSB concept used by StegHide, or is that a separate thing entirely? Yes, StegHide does use the LSB concept. This challenge specifically, you will be able to find the .text file or the flag because it has been embedded into the image file with LSB Steganography. Hope that answered your question. So it looks like a few guys have found a flag from this challenge, which is really awesome. Keep it up. Remember, you can, once you found your flag, you can find our bot Orchid on the Discord and DM the flag to it, and you'll get some cool Discord internet points. If you guys are struggling with the second flag, because there are two flags within our birds file, think about the actual picture itself. Maybe take a look at some of the details inside the picture. So remember, I said forensics requires you to be very clever to figure out data or information from a flag. So yeah, take a look at the actual image. Maybe that'll help. I'll give you guys a few more, or maybe 10 more minutes to do this. Someone is asking if flags are case sensitive. The answer is yes. Make sure you have your cases correct. All right, I think I'm going to give you guys one more hint for this challenge. Let's take a look at the file together. So it's pretty interesting. It's a pretty lovely picture of birds on a like a telephone line. If you'll notice, maybe these birds are in sort of like one of two states. They're like facing forward or like facing to the side. So they're in one of two states. Yeah, maybe some of you have noticed that birds are pointing in different directions, or they're facing forward, or they have their tails out. Perhaps this is the birds are representing something that we must translate. I don't know. I'll let you guys think about that. All right, guys, so I hope you had fun with this challenge. Hopefully some of you guys found the flags. I'm going to go over our solution here. So to find the first flag, we're going to use the staghide command that we just learned about. So it's staghide extract -sf, and then, actually, we should go into the proper directory first. Okay, and now we can run our staghide command, enter passphrase. I don't think there's any passphrase. Let's just leave a blank passphrase. Okay, now it says wrote extracted data to words.txt. So they created a .txt file. Let's take a look. Interesting. So we've got a lot of text here. They sort of look like they might be parts of the flag. You can probably look through this entire file and look for the flag. That might take kind of long. Another easy way we can do is using grep. So we're gonna do the command grep, and then the prefix for our flag, and then it should be in the words.txt file. And there we go. UC seg, birds of a feather flock together. So that's where our first flag is. If you're looking for the second flag, you can take a look at the image here. See if I can zoom in a bit. So you'll notice, maybe you notice there's like a secret curly brace here. There's a secret dash here. Another secret curly brace. So perhaps these birds are trying to be some form of representation of the flag. And the other thing you might have noticed is there's two types of birds. There's birds standing sort of upright and birds with their tails out. So it could be binary, maybe one of two states. It could also be Morse code, which is what it happens to be. So this beginning part is Morse code for U, C, S, E, C. So that's our flag prefix, and then the rest of the birds will spell out the second flag. So I won't show this to you right now. If you want to do it on your own time, get more internet points, by all means, go ahead. But yes, that's how we do the second flag with Morse code. All right. And if you guys have any questions, just ask in the chat. All right, we're going to move on to part 2, file signatures and spectrograms. So a file signature is basically sort of like the extension of the file, like a .jpg, .png, .wav. Those are all extensions of a file. And typically, you would think that they tell you what type of file it is. So a .jpg is an image file, logically. But this is sort of like a misconception, or it's not always true. A file extension does not always determine what the file type is. If you want to know what the file type is for sure, you should look into something called magic bytes. And so this little picture down here is data of a file, and it tells us on the top here, these are the magic bytes .png. So we know this is a PNG file for sure. So the magic bytes are within the byte data. The other thing to note is sometimes multiple files are concatenated together. So what concatenating means is basically you have two separate files and you're sort of attaching them together so that all of the bytes of the first file are in the first half of the file and all of the bytes in the second are in the second half. So it's like squishing two files together into one file. Maybe I can demo concatenation if I have two pictures here. So I have birds.jpg and nest.jpg. If I run the command cat birds.jpg and then to nest.jpg, what I'm doing is concatenating both of these files together and putting the resulting one in nest.jpg. So you'll notice if we open nest, looks the exact same. Can't really tell that there was another file smushed behind there. So how can we really know if there was two files that were concatenated together if we can't see it in the image? We can use file signatures to determine when one file ends and another file begins. So one way we can do this is with the tool called Binwalk, which you should also have installed in the beginning. We can use Binwalk to find all the file signatures in a file by using the command binwalk and then the name of our file. And then additionally, we can put the -e within the command to extract this data. So what Binwalk does, it basically walks through the entire binary file and it looks for file signatures. So not just in the beginning, it looks through the entire file to see if there's any signatures. Another thing you might have heard of is the file command. It can also determine file types. So if we do file nest.jpg, it tells us it's JPEG image data. So that's another way we can determine what types our files are. The thing with file is it'll only look for one file signature versus the other one, Binwalk, will look through the entire file. All right, so that was Binwalk, and now this is audio spectrograms. So as I mentioned, a spectrogram is a visual representation of frequencies in an audio file. So if you think of like sort of colorful thermo-colored waves, that's basically what an audio spectrogram is. And what we can do is hide information, like hide text or images within the spectrogram. And we can use analyzers to see those messages. And there's lots of online spectrogram analyzers. There's also Audacity, which I think is installed on Macs. It's a separate program that analyzes spectrograms. So here's an example of what a spectrogram looks like. This is a very cool website called Music Lab Chrome Experiments. And if I start speaking, you can see it's picking up my voice and creating a spectrogram. So this is what a spectrogram looks like. And then we can do other stuff like, I'm not sure what this is. Oh, I see. So I'm moving my mouse to create pitches, and then it's creating the spectrogram. So very cool. You guys can take a look, do your own experimenting. This is a really cool website. Spent hours on it personally, but okay. So when we come across an audio file, if you hear something weird in it, like some strange pitches or like the sound of a fax machine, oftentimes that'll give you the hint that there's something there's some sort of embedded information within this audio file because we've sort of artificially added these frequencies. So it'll sound really strange on the audio side. Someone is asking a question. Where does Binwalk extract to? I tried Binwalk-eBirds. It should extract to the directory that you're in. Like, for example, I was in my desktop and I pressed Binwalk and then... Oh, wait, sorry. I'm talking about something else, aren't I? Yeah, sorry. This is something different. But I'll show you how Binwalk works. I'm not sure about the MySQL message, but maybe we'll figure it out. So we talked about Binwalk and we talked about audio spectrograms. So now we have a second challenge here. So visit the link to go to download sun.mp3 and see if you can find the hidden flag. There's only one flag. So use your tools and see if you can find the flag. I'll type this into the chat. All right, good luck, guys. All right, Nicholas, you're on the right track. Keep working through it. Just remember you should be only using either the spectrogram analyzer or the Binwalk command. Those should be enough for you to find the flag, but you're on the right track. Joshin asks, was this created like how you showed us with cat or file? I should mention I was not the original author of these challenges. That credit goes to James, another, or I guess an ex-member, ex-executive of our group. So he created all of these challenges. And yes, I agree. They are very cool. Anyways, how are you guys doing with this challenge? Do you think you're on the right track? Do you guys need any hints? Let me know. All right, so it sounds like some of you guys managed to get the flag, which is really awesome. Good for you. You guys should be competing in CTFs. Do it. Anyways, I'm going to go over the solution for how to find the hidden flag in this one. And if you're still working on it, keep working at it. So here we are in my Kali desktop. And we have, I believe, we have the sun.mp3 file here on my desktop. What we're going to do is try the binwalk command. Binwalk-e sun.mp3. Let's hit it and see what happens. All right, so it took a few seconds, but it spit it out. Something kind of interesting here. So as you can see, it created a extracted file on my desktop called _sun.mp3.extracted. So it's telling me that it seems to have found something zip archive data, right? So let's go into that, see what it's given to us. It has 1DEA93.zip and a WAV file combined.wav. So basically, this is the zip file that was found from the binwalk command, and binwalk was just nice enough to extract it out and give us this WAV. So if we take a listen to the combine.wav, I think it'll probably sound pretty strange. I can't show it on the stream, but it sounds sort of really strange and pitchy. So let's do our next step, which is to binwalk this one as well. Or, sorry, actually, we have to do the next step was to put binwalk in a spectrogram analyzer. So this is the one I put into the chat. That's just like sort of the first spectrogram analyzer that pops up when you search it on Google. Let's browse our file, select combined.wav, and let's see what the spectrogram looks like. So now you can see here, there's a message here. It says the long and winding, wait for it. Okay, it says the long and winding road, which I believe is a reference to a song by the Beatles. So we have that. Well, you might notice it's not in the typical flag syntax with the UC-sec and the curly brackets. So if we try entering this into ORCID, it won't work out. But it's interesting. We found something, so I think we're on the right track. Let's see what happens if we binwalk the combined.wav file itself. So binwalk-e and combined.wav. It's going to take a few seconds. It's going to tell us, oh, look, it found something else. It's another zip archive deb, which I think they created. Yeah, so they created another thing called combined.wav extracted. So let's take a look at that. Let's go into the directory. And it's showing us there's a flag.jpg here. So let's see. Actually, let me use the GUI because I guess it's easier. So we go into this, and it says flag.jpg. It's allowing us to open it. I'm not sure if it's showing anything. Oh, if we go in here. Yeah, that's one. So if we go in there and click on flag, it's asking us for a password. Well, we did get this strange sort of cryptic string. Maybe that's the password. Let's see if it is. So enter the password. So it's not going to let us access the JPEG if we don't enter a password. So let's try this. Long and winding road. You can't see that I was typing it, but that was the password, and it worked. here's our flag for the second challenge. You see files and files and files. So yeah, I hope that was a pretty cool demonstration about how Binwalk works and also how you can sort of cache data, or I guess hide data, in spectrogram analyzers. And yeah, if you guys have any questions, otherwise we're going to move on to part 3, mounting file systems. So mounting and unmounting is a pretty useful skill to know in general, like using on the Linux system. It's not really specific to forensics or specific to cybersecurity at all. It's pretty useful to know. So what we're basically doing when we mount and unmount file systems and images is we have a special file with the extension .img or .iso. So a .img is a image of a disk, or an ISO is an exact copy of an optical disc, such as like a CD, DVD, Blu-ray, I think, maybe Blu-ray. And what we have to do is we have to mount these special files first before we can read or write to them. So we need to use we need to use the command mount in Linux here, mount, to mount the file system. And then this enables our OS to access the file, essentially. And conversely, we use umount. Be careful, it's U-M-O-U-N-T, not unmount. Not sure why they left out the N. It's just a single letter. But if that's how Linux wants to do it, so we use mount to mount things and umount to unmount things. So I'm going to show you guys how to do this specifically. To mount an image, we're going to make a new directory. You can make this directory anywhere, as long as you have the permissions to make it. So just like your desktop, you use make directory, mkdir, and then the name of the directory you want. We can just call it temp for now. You might need to use sudo. You probably won't, though, if you're just making a directory on your desktop. The second step is to mount the image file. So you type sudo mount the name of the image file and into our directory that we just created, which was temp. And then finally, we can switch to that directory that we just created using cd or change directory. So to unmount an image, we use the command umount. So sudo umount temp, which is the directory, if you remember. And the second step we have to do is just sort of remove the directory that we created using rm. And then this -r is recursive remove, so it removes all of the directories and subdirectories within temp. So it's always important to unmount the file after you're done reading or writing or doing whatever you want with it. All right. So here's a little analogy to help you understand. Mounting and unmounting is sort of like plugging in and unplugging a flash drive. So you should be plugging in the flash drive first in order for your computer to read the data that's inside the flash drive, and you should be safely unplugging it. You should be safely unplugging it when you're done using it. Okay, so that was mounting and unmounting. Here's a sort of general forensics tool that you might that might be helpful to know. Recursive grep. So we went over grep in previous workshops. I think in the first workshop we went over grep. If you'll remember, it's a tool to use to search for patterns in a file. So we also used grep in the first challenge in the birds.jpg or the words.txt file to find the flag. And the command grep is typically used on a single file. But if we want to look through an entire directory or a directory and all of its subdirectories, we can use recursive grep. So that's grep-r, R for recursive, and then the pattern we're looking for, or the string of text that we're looking for. So that's a really useful tool. If you don't want to look through every single directory individually, you can look through an entire one with recursive grep. And also here at the bottom, you can look at the manual by typing man-grep for more information. All right, so this brings us to our final challenge. So visit the link to download this .img file, challenge.img. Here's a few tools that we just went over. Recursive grep with this command. Binwalk if we're looking for file signatures, maybe files that are concatenated together. So those are two useful tools. And also these are the commands for mounting and unmounting the image file. So first we're going to have to do the mounting. Then we can look for flags within the file. And then when we're done, we unmount it. So yeah, there's four, it's a big number, 4 hidden flags in this challenge. I'll give you guys 25 minutes to do this. Good luck. I hope you find them all. I'll also paste this into the chat. All right, how's everybody doing with the challenge? We're about 5 minutes in. Was everybody able to mount the image file? If you are having trouble, maybe I'll just give a demo so you guys can start the challenge. Oh boy. Let's get rid of some of these things here. Okay, so we have our challenge.image file. I'll demonstrate the mounting first. So I'm just gonna look at my notes there. So we're gonna make directory called temp. Oh, sorry, I'm not in the right directory. So we're gonna do that again. Make a directory called temp. Cool. Did it do that? Oh no, I'm still not in the right directory. Okay, now I'm in the right directory. Let's try that one more time. Okay, yeah, so now we have our temp. What we're going to do is sudo mount challenge.img into temp. I think that should work. And then it'll ask you, it'll prompt for a password. Okay, so we've mounted now. I think that's everything, right? Yes, so that we have successfully mounted. Now let's take a look what's inside our temp. cd temp. Just look at that. There's a bunch of files here, or a bunch of directories. I guess we're going to have to use some. Well, we know there's going to be 4 flags somewhere in all of these. It's probably an easier way than looking through each directory. Let's use some of the tools that we learned. So yeah, if you guys have any questions, of course, ask in the chat. But yes, that's how you mount. All right, I'll let you guys continue with the challenge. All right, folks, how's the challenge going? Hopefully you're finding some flags. If you're not, don't worry about it. I'm here to give you guys a hint. So let's take a look at, again, the file system that we mounted. So you may or may not be familiar, but this is pretty similar to what a Linux directory or a Linux file system will look like from the root. So if you've participated in previous InfoSec challenges, a good hint is to always look in home for one and root. So look in home and root, see if you can find anything there. And Nicholas has found all 4 flags. Wow, VIP, very impressive. But I'll give you guys a few more minutes to work on this. But hopefully that helped. All right, so thanks for sticking around, guys, to the very last challenge. Hopefully you guys found some flags. I'm going to go over the solutions to find our 4 hidden flags in this image file. Okay, so here we are in the temp directory where we mounted the challenge.img. To find the first file, let's try using recursive grep. So recursive grep, to recap, what's going to do is look through all of the directories and subdirectories within temp to look for our desired pattern, which in this case is ucsec curly brack. Ooh. Okay, so it's telling us 2 things in proc /bus/PCI/ rare. Okay, I can't pronounce that word, but it said there's a binary final that matches the pattern we were looking for. And then the second thing it says, it was unable to look and lost and found. Okay, whatever. Let's just leave that be. But let's go to this directory that they told us, proc /bus/PCI. There's our file, ryrdmlhr. It's sort of gibberish, but after that, we should use the strings command. So what strings is, it extracts text from a non-text file or binary file, which this is. So let's see if we enter strings, and there we go. We have our first flag. ucsec grep is really powerful, and indeed it is. Okay, let's go back now. Okay, so we're back in the temp. The next flag we're going to do is by looking in home. So as I think Alex mentioned above, looking in home or root are really great places to look, is because usually where people write their files, not the actual machine. So that was great information. So let's look into home, see what we find. Okay, we have another folder called Magpie, cd Magpie. Now let's see what's in it. We have a journal.txt and a welldone.png. So we can open well done. Let's see. You can do this. You can do this using the actual file finder, or you can do it over command line. But look, we found a second flag. ucsec, good job for looking in home. So yes, you should always look in home because it'll pay off. Okay, so we found 2 flags. We got 2 more to go. Let's see what's in this. Let's see what happens if we. Yeah, I think we should binwalk next. Use our binwalk command on welldone.png. See what happens. So if we binwalk welldone.png, interesting. It says zip archive data. We have found another thing called wellhidden.jpg or JPG. So let's take a look at that. I think we have to go into there first. And then open up well-hidden. Well-hidden.jpg. Let's see. Would you look at that? Binwalk is awesome too. It is very awesome. So that's our 3rd flag. 3 out of 4. So we have 1 more flag. I think we saved the best for last, or perhaps the hardest for last. Let's go back a few to see. Yeah, so we're back in Magpie. So we talked about well done and well hidden. What about this journal.txt? Let's see what's in it. Dear diary, today I had the most amazing day. Blah blah blah. Looks like a diary entry. A diary entry from a Magpie. And oh, look at that! It's telling us the password is magpies love to fly. Sounds like important information. Let's keep that in mind. What should we do next? Let's go back. So we're back in temp here. Remember my hint, I said to look at home, which we looked at. Another one we should look at is root. So let's look at root. See what's in root. Okay, we have some sort of gibberish files. We also have this lockbox.zip. Interesting. Let's see if we can open it. Yeah, I think I'm going to use the. So we went to root, we have lockbox.zip, and here we found flag.txt, which is where our fourth flag is. Let's see. Oh, it's telling us once again a password is required, but luckily we did find our password within the home directory, and it was magpies love to fly. Hopefully I entered that correctly. Let's try that again. Oh, I think what I have to do is unzip it first. Is that right? Yeah. So I think I can use unzip.p-p for password. Or okay. Sorry for this last flag. So you're supposed to unzip the lockbox.zip. I thought there was a way to do it just by looking in. Oh yeah. So let's press extract here. Just onto our desktop. And now it's asking us to enter password. There we go. So we've extracted it with the password, and let's open up our flag.txt, which is still showing us nothing. I'm not sure why it's not showing anything. Maybe I'm entering. Okay, I think I might be entering the password wrong or something. But basically, if you unzip the lockbox and open the flag.txt with the right correct password, which is which was up here, magpies love to fly, you should find the final flag, so the fourth out of 4, and that last flag will be, it'll say UCSec passwords keep things secure in lead text. But yeah, that's essentially the final challenge. For bonus, we have extra related PicoCTF challenges. So if you've heard of PicoCTF before, they're a CTF that happens every year from a different university. There's some 2018 and 2019 challenges that are related to some of the tools that we talked about today. Feel free to give these a try. And finally, we have
I think Justin has frozen.
hello. Am I back?
Oh, you're back.
Sorry about that. That was my internet. I apologize. I was just saying we have a bonus challenge here. I'll paste it into the chat. Colors.png. There's one flag that to find here. And a little tip is to think about how color can be represented. Ooh, fun tip. I think that's everything. So yeah, thanks for listening, guys. I hope you learned a lot. I hope you had fun. I hope those challenges were challenging and also very entertaining. But with that, I guess I'll pass it back to Alex.
I want to thank Justin for holding the workshop this week. I think it was super fun and everyone learned lots, and we're finally getting more into what people would consider being like hacking things. Other than that, I just want to remind everyone to please fill out the attendance. I think I can post the link. 1 second. I have to copy it. It is, first of all, your first step into becoming a full voting member, which will allow you to vote in the AGM for us. It also just helps us to see who's coming to our workshops, if they're interesting, when attendance drops down, etc. It's just interesting to us. If you're a student, you can fill out zero, and if you're not a student, you can fill out 0 on the UCID. Also, the SU asks for it. That's why we ask for your UCID. They just want to see that people actually come to our workshops and that we're not just a fake club. Other than that, we do have junior exec applications. We're accepting junior exec applications right now. They're due October 15th at midnight. You send them to our email, which is infosec.ucalgary@gmail.com. If you missed the meeting that we had on the 29th for junior execs, please reach out to me or Josh on Discord or email the club, and we will set up a time to just explain everything to you and give you that application. You don't need to have any experience to be a junior exec. You don't need to know anything about information security. If you're a first year and you don't know much about computer science at all, that's not a problem. We expect that out of junior execs. So please, if you're at all interested, don't be afraid to apply. Other than that, I just wanted to remind everyone that next week is Thanksgiving on Monday, so we will not be having workshops. And then the week after that is our first entry of our speaker series. We have Chris Shepard coming in and giving a presentation on open source intelligence. If you participated in our CTF last year, we had quite a few challenges on open source intelligence, so it would be fun to go to that. If you want to go to that, you do have to be a premium member. So you do have to e-transfer us $10 to our club account and send us your Discord identifier. With that, we will then give you access to the speaker series. The speaker series is one of my favorite parts of our club. It gives you access to industry members and just like learning things about cybersecurity as an industry. So it's super cool to see that. $10 really isn't that much, and it really helps out our club. So if you want to come 2 weeks from now, not next Monday, the Monday after that, then please e-transfer our email with $10. Your email and the Discord identifier so we can change your role within our Discord. Other than that, that's all we have for tonight. So I hope you guys have a good rest of your week and see you 2 Mondays from now. Bye.